This is the last lesson of the unit. So hooray, we're almost done with proofs. Now this one we're going to learn how to solve with identities. So we solved equations in the last unit using inverses and those kind of things, and now we're going to have to use identities first. Now, a note about the examples. So these ones, there's no like good example practice setup. So there's 3 examples. They're all possibility. I just pulled them from the possible homework problems. And then there's 3 practice problems. So they don't necessarily line up perfectly, okay? Because you're going to be using any identities to solve these. So the identities I use in example 1 might not be the same identities you use in example 2. So we're going to use identities to solve. You still have to use inverses and all that kind of stuff. So the process is still the same, but the examples, there's really no difference in all the 3 examples. They're just more of the same kind of thing. So if I want to solve this problem, I can't solve it as is because I have a 2x and an x. If both of these were the same, that would still be difficult too. So I need to set it up so that I can solve. So I'm going to use my addition to, or I'm going to change the sine x to sine 2x to sine x cosine x. And then I'm going to factor out a cosine x. So you see, you have to be thinking about what are possibilities here. Then I have cosine x equals 0, and 2 sine x plus 1 equals 0. Okay. And so cosine x is pi over 2 plus 2k pi, and negative pi over 2 plus 2k pi. Then I have sine x equals 1/2, or negative 1/2, I apologize, which gives me, and there's different possibilities here depending on where you look on the unit circle, 7 pi over 6 plus 2k pi, and then a negative pi over 6, if I did pi minus that, plus 2k pi. So again, the only difference in this problem and the ones we solved before are the fact that we have to use identities before we can start simplifying. All right, so practice problem number 1. Maybe? Okay. So this one we have a cosine x and a cosine 2x. I can recommend that you go ahead and change this to get rid of the double angle, or the 2 in there. Try to use that identity and then see what you can do. All right, so here's what they did. They changed this to 2 cosine squared x minus 1, because that's what cosine 2x equals. And then they simplified, and then moved the pieces around and factored, and then we're able to solve for both of them. And then use calculator. Obviously, this one has no solution, and this one was 0.8411 plus 2k pi and negative 0.8411 plus 2k pi. Okay. Again, the only difference is we had to use the identities to get us to the point where we could start solving. Okay, example 2, sine of x over 2 equals 1 minus cosine x. Okay, we need to get this to a point where we can solve it. So we're going to start by changing sine of x over 2 to the plus or minus the square root of 1 minus cosine x over 2. This is a really complex problem, by the way. And then I'm going to square both sides. Okay. And then once I square both sides, I'm going to simplify. So it's 1 minus cosine x over 2 equals this squared. 1 minus 2 cosine x plus cosine squared x. Okay, now the next step is something that a lot of you aren't totally familiar with. You should be at this point, but it's not something you use a whole lot. We want to get rid of the denominator so that we can start moving things around. So I'm going to multiply the entire equation by 2. What that does is that gets rid of this fraction here. And then I would have to multiply that by 2. Right? And I can do this because the rule, it says that when I multiply one side by something, I can multiply the other side by it. So multiply the whole thing by 2. And I'm left with 1 minus cosine x equals 2 minus, that should be 4 cosine x. I wrote that down wrong. That should be 4 cosine x plus 2 cosine x. The whole thing's multiplied. I wonder if I caught that. Nope. Okay. We're actually going to move this over here, but we're going to invert the equation. So I'm Okay. So I get 2 cosine squared x, if that was really 2 cosine x, minus 3, because this should be 4, and negative 1 is 3, plus 1. That equals 0, and now I can factor. And then once I factor, I can solve. Okay, just like I had before, so cosine x equals 1/2, and cosine x equals 1, which is pi over, this one is pi over 3, and negative pi over 3 plus 2k pi, and cosine x minus 1, cosine x equals 1. Which is 0 plus 2k pi. Alright, so here's another practice one. Okay. Again, because you have a sine x and a cosine x, it's really hard to solve. So try to make this so that you only have one, either a sine x or a cosine x. Well, no, that's not necessarily it. It's just the fact that they're multiplied together. We can't solve it that way. So find a rule that gets rid of that. So I can use a double angle identity. Okay, I can use the double angle identity to rewrite. So 2 sine x cosine x equals sine 2x is the same thing as sine x equals 1/2 sine 2x. So I'm going to rewrite it like this, which then I multiply both sides by 2, and I have sine x equals 2, or sine 2x equals 2. This has to be between 1 and negative 1, so I can't solve it. Okay. Example 2, sine 3, sine 4x minus sine 2x. Okay, this is going to be really similar to, I think, example 1, when we were working on that. So I'm going to use a double angle identity. So I get 2 sine x, sine 2x, cosine 2x, minus sine 2x. Now, I could use a double angle identity again, but that would make this more complex. So I'm only going to, because since they all have 2x in it now, I can just factor out. So I factor out a sine 2x, and I'm left with 2 cosine 2x minus 1 equals 0. So then I have sine 2x equals 0, and 2 cosine 2x minus 1 equals 0. Okay. And then I'm going to solve like I have before. Okay, 0 plus 2k pi, and pi plus 2k pi. And now I need to set this equal to 2x and divide, and I end up with k pi and pi over 2 plus k pi. Now this one's pi over 3 plus 2k pi, and negative pi over 3 plus 2k pi. And then I'm going to also do the same thing, divide everything by 2, and I get pi over 6 plus k pi, and negative pi over 6 plus k pi. Okay. Here's your practice problem. Okay, think about what rules you could do to simplify this. And continuing on. Alright, so since cosine squared x minus sine squared x is cosine 2x, I can change it to cosine 2x equals 1/2. And then I can solve just like I have before. Alright, so I will see you tomorrow.